Dear students, welcome to the Army Public School PMA Resource Network. Before we start our today's subject, Maths, please subscribe this page and click on bell icon to receive the upcoming notifications of our channel. In our today's subject Maths, we are going to discuss integers. This video is about the negative numbers and arithmetic operations involving them. In this module, we will learn to use negative numbers in real life and how we can represent the numbers on a number line and order them. Furthermore, we are also going to learn how to find the absolute value of an integer and how we can perform arithmetic operations on integers. In our daily life, we count various things for various purposes. We count things using counting numbers. The numbers 1, 2, 3, and so on are called counting numbers or natural numbers. Natural numbers are denoted by n and are defined by the following set. Let's suppose you have a basket of apples and someone takes them away, and you are left with an empty basket. Now there is nothing. What number will represent this notion nothing? So here comes another number, that is 0, which represents nothing. Or we can say that 0 means nothing. The whole numbers comprise of the entire set of natural numbers and 0. An important thing is that the numbers which are greater than 0 are called positive numbers. We have numbers like 1, 2, 3, and so on so that we can count. We also know why we have a 0. Now the question is why we have negative numbers. Negative numbers are the numbers that are less than 0. Imagining something less than 0 can be difficult. However, there are instances in real life where we use numbers less than 0. For example, do you know the average temperature at the top of Mount Everest ranges from negative 19 degrees Celsius to negative 36 degrees Celsius. Negative numbers also appears in finance to show loss in amount. Suppose you gave your friend 100 rupees and that friend returned just 50 rupees. What is the net amount you have now? The net amount you have is minus 50 rupees. We know that there is no note available in market which amounts to minus 50 rupees. But negative sign tells us that you are in a loss. Now let us see what are the negative numbers and how they look like. A negative number is any number that is less than 0. For example, negative 7 is a number that is 7 less than 0. A negative number is represented with a negative sign or a minus sign. Let's see how we can differentiate a positive number from a negative number and how it looks like. Any number without a negative sign is called a positive number, which means a number that is greater than 0. So 7 is a number that is 7 greater than 0. A positive number is represented with a positive sign or a plus sign, but usually this sign is hidden. Now have a look on integers. The numbers 1, 2, 3 and so on, their opposites -1, -2, -3 and so on, and the number 0 together form a set of integers. Let us understand the set of integers with the help of following diagram. In this combination, each shape represents a particular number or set of numbers. As you can see, the circle represents 0. Next shape represents natural numbers. The rectangle represents whole numbers. The triangle represents negative numbers. And the last shape represents the integers. Integers are denoted by z and are defined by the following set. The numbers 1, 2, 3 and so on are called positive integers, and the numbers -1, -2, -3 and so on are called negative integers. And what about 0? 0 is neither a positive nor a negative integer. And another thing to remember is that the set of integers does not include fractions or decimals. As we have understood what are integers, let me explain how integers can be represented on a number line. Integers can be represented on a number line that extends to the left and to the right. It is indicated by arrows. The positive integers are represented to the right of 0 and the negative integers are represented to the left of 0. The value of number increases as it moves away to the right from 0, and the number of value decreases as it moves away to the left from 0. An integer on the number line is greater than the number on its left side and less than the number on its right. For example, -1 is greater than -2, -1 is less than 0, and 4 is greater than 2. Now let us see what is the absolute value of an integer or a number. The absolute value of a number just tells us its distance from 0 on a number line. It is represented using vertical bars to the left and to the right of a number. The absolute value of -3 is just asking us how far is -3 from 0. As we can see, it's 3 units away from 0. It's simply the distance between -3 and 0. And remember that distance is never negative. We cannot say that it is -3 units away from 0. So, as the distance between -3 and 0 is 3, we say that the absolute value of -3 is 3. What would be the absolute value of 3 then? Let's see how far is 3 from 0 on a number line. Again, it's 3 units away from 0. So the absolute value of 3 is also 3. So we conclude that the opposite integers have the same absolute value. What will be the absolute value of minus 5? As it is 5 units away from 0, it will be 5. Absolute value of 8, it will be 8. Absolute value of minus 154, it will be 154. Look at all the answers. They are all positive. So would it be right to say that the absolute value of a number is always positive? Let us check the absolute value of 0. 0 is 0 units away from 0. Is 0 a positive number? No, it's neither positive nor negative. So we should say that the absolute value of any number will never be negative. It will be 0 or positive. Now, let us look at different situations where we categorize a number either as positive or negative. Height above sea level is marked as positive, whereas depth below sea level is marked as negative. Money earned or deposited is marked as positive, whereas money owed or spent or withdrawn is marked as negative. Climbing up is marked as positive, whereas coming down is marked as negative. Highest temperature is recorded as positive, whereas lowest temperature is recorded as negative. As we have learned so many things about integers, now let us discuss various arithmetic operations on integers. Applying these operations on whole numbers is pretty easy because we used to add, subtract, multiply or divide just two positive numbers. Whereas on integers it is quite complicated because here we also have negative numbers. Let's first discuss the addition involving negative numbers. Here you have to remember just two rules. While adding the integers with like signs, add and keep the sign. For example, when we add positive 2 and positive 5, the sum is equal to positive 7. And when we add negative 2 and negative 5, the sum is equal to negative 7. And the second rule is, while adding the integers with unlike signs, subtract and keep the sign of larger integer. For example, when positive 2 is added with negative 5, the sum is equal to negative 3. And when negative 2 is added with positive 5, the sum is equal to positive 3. Let's discuss the subtraction. Again, here you have to remember just two rules. First, while subtracting the integers with like signs, subtract and keep the sign of larger integer. For example, when positive 2 is subtracted from positive 5, the answer is negative 3. And when negative 5 is subtracted from negative 2, the answer is positive 3. And the second rule is, while subtracting the integers with unlike signs, add and keep the sign. For example, when negative 5 is subtracted from positive 2, the answer is positive 7. And when negative 2 is subtracted from positive 5, the answer is negative 7. Let's see how integers can be multiplied. Again, here you have to remember just two rules. First, if the signs of integers are same, then the product will be positive. For example, when positive 4 is multiplied with positive 6, the answer is positive 24. And when negative 4 multiplied with negative 6, the answer is again positive 24. And the second rule is, if the signs of integers are different, then the product will be negative. For example, when positive 4 is multiplied with negative 6, the answer is negative 24. And when negative 4 is multiplied with positive 6, then again the answer is negative 24. Now let's understand the division of integers. First rule of division is, if the signs of integers are same, then the quotient will be positive. For example, when positive 8 is divided by the positive 4, the answer is positive 2. And when negative 8 is divided by the negative 4, the answer is again positive 2. And the second rule is, if the signs of integers are different, then the quotient will be negative. For example, when positive 8 is divided by the negative 4, the answer is negative 2. And when negative 8 is divided by the positive 4, the answer is again negative 2. Let's talk about the square root of a positive and a negative number. As we have studied previously, that a square root is a number raised to the power 1 by 2. Square root is the inverse of squaring a number. The radical sign is used to indicate the square root. And a positive number has two square roots. As you can see the example, if we find the square root of 64, then there are two possibilities. 64 can be written as 8 multiplied by 8 or minus 8 multiplied by minus 8. So 64 has two square roots. One is positive and the other one is negative. And what about the square root of a negative number? If we find the square root of minus 64, then again there are two possibilities. Minus 64 can be represented as plus 8 multiplied by minus 8, but we cannot express this product as the form of index. So the answer is undefined. Same goes for the second possibilities. So we conclude that we cannot find the square root of a negative number, or we can say that a negative number has no square root. Now let's see what do we mean by the cube root of positive and negative numbers. A cube root is a number raised to the power 1 by 3. And cube root is the inverse of finding cube of a number. The radical sign having index 3 is used to indicate the cube root. And a positive number has one cube root. As you can see in the example, 64 can only be represented as the cube of 4. So it has one cube root. And a negative number, that is minus 64, it also can only be represented as the cube of minus 4. So it has one cube root, that is minus 4. So a positive number has one cube root and a negative number also has one cube root. The next thing which we are going to learn is the combined operations on numbers. In previous classes, you have already studied BODMAS rule. Now let's revise order of operations as per BODMAS rule. Whenever we have to solve an expression having combined operations, we need to follow the order of operations. What is this order? First, we have to solve the parentheses or brackets. Perform operations within parentheses. Then we have to solve the exponents, which are also known as powers or indices. Find the value of all exponential expressions. Then comes multiplication and division. Perform all multiplication and division in order from left to right. And in the end, addition and subtraction comes. Perform all addition and subtraction in order from left to right. And a great way to help you remember the order of operation is the acronym. Please excuse my dear Aunt Sally. Before assigning you home task, I would like to share few points that you need to remember in order to do your assignments properly. Draw a number line putting the positive symbol on the right side and a negative symbol on the left side. The number value increases as it moves away to the right from 0, and the number value decreases as it moves away to the left from 0. Use the absolute value as a distance from 0 on the number line. Take the absolute value of an integer to make it positive. Remember the rules while you are adding or subtracting the integers. And you also must be careful about the rules while you are multiplying or dividing the integers. This is your assignment related to chapter number 2. Solve these questions with proper steps and submit it on AIS. In week 5, you have to do practice nows from page 28 to 37. Then you will do selective parts of questions from exercise 2A and 2B. And in week 6, you will solve practice nows from page 40 to 42 and some parts of questions from exercise 2C. Thank you for watching this video.